Hello, my name is Craig Belgrad, and this is the Test 3 Wrapper videos. And the whole point of wrappers is to go over the past test and kind of go over a question in detail, a question that might have given a lot of trouble people a lot of trouble on the test. And it's the presenter's job to go through the question step by step and provide kind of steps to how they get the solution. And this is kind of used as a study aid for not only for other students, but even for me as well, just to kind of like reinforce the knowledge. So the question I chose from the last test was question 2, and it reads like this. 3 identical batteries, each with an EMF equal to V, are connected to 6 identical resistors, each with resistance R, as shown in the diagram below. So you have the little squiggly lines as resistors, you have 6 of those, and you have 3 straight lines, which are batteries, and then you have the node points around the whole circuit. So the first question wants you to find the current I, where the current I in the circuit is. So it doesn't really matter which way you go around the circuit, but you just have to be wary of the sign. So the potential difference between 2 and 1 would be negative IR, between 2 and 3 would be negative IR as well. But when you pass over a battery, depending on which way you go, it'll be either positive V or negative V. So in this case, I just choose negative IR plus V. So every time you pass over a node, it's going to be negative IR. Or every time you pass over a resistor, it's going to be negative IR, and every time you pass over a battery, it's going to be plus V. So you end up going to have 6 negative IR terms and 3 plus V terms, and you just do some algebra, and it'll just equal 3, V equals 6 IR. So when you do the algebra, and when you find I is equal to V over 2R. So there's that first part. Then the second part is part B, find the potential difference between V1 and V3. So you go up here, you see where you cross over. So you're crossing over 2 resistors. So delta V1 minus delta V3 equals delta V31, and that equals delta V32 plus delta V21. You're just passing over the different resistors from point to point. So you're going to have 2 IR terms, and that in 2 IR terms equals 1 V. So then just delta V1 minus delta V3 equals V. As you can see, these 2 IR terms equals 1 V term based on the ratio. So you have, this is double what that is worth. So now the third part is the potential difference V5 minus V8 is, so you kind of do the same delta V manipulation up here, but you go back and look over your diagram. So you're passing over 2 resistors and 1 battery. So you're going to have 2 IR terms and 1 V term. So you're going to have IR minus V plus IR, and depending on which way you go, if you go one way, you could have positive IR or negative IRs, another way you could have positive IRs. But your IR and your V signs are always going to be different. So you're going to have, by the end of it, you're going to have 2 IR minus V, and 2 IR equals a positive V, so positive V minus positive V equals 0. So 2 resistors over 1 battery gives you a potential difference of 0. So then the fourth question in this case was graphing. So you had to make a graph as you went around the whole circuit what the potential difference was going to be. So we know that going from 0 to 1 in this case would give you just a positive V, but if you go over over 2 spaces, you're going to go back down to 0. That's demonstrated here. So 1, 2, 3 would give you or if you go over from 2 places, I should say. So you start at point 1, you go from point 2, you go through point 3, you'll get 2 IR. But if you go through if you go over 3 to 4, which is your third location, you're going to end up going back to 0. So that's what this graph is trying to show you. So every 3 places, you're going to start from 0, you're going to go up 1. But the more you go down, the more spaces you go, 3 spaces over, you're always going to end back up at 0. And when you're at your last one, when you're at position 9, and you go to position 1, you're going to end up at positive E. There is really no 0 node, but I guess for the sake of continuity, you could probably say from 9 to 1, at least in the beginning. That could be your 0 term at the beginning, but that's just compensating. So when you go back to you go from 0 to 1, you're going to get V, but if you go over 2 spaces, you're going to go back down to 0. So that's just what that graph is trying to show. So all in all, not a typically difficult question, but certainly a very tricky one if you don't know the concepts entirely well. You just have to know that delta V equals IR. Going through your resistor, you're going to have IR and whatnot. Going through a battery, you're going to have delta V. And it's just, matter of algebraic manipulation and just kind of placing your terms in the proper places. So I hope this helped. This certainly helped me kind of going over it myself. And I hope this helped a lot of you kind of look over your mistakes and learn from your mistakes. And I wish you all the best on the next test and the final exam.